What if the thing we are most certain about is the thing that is most wrong? Not gravity, not the speed of light, not the age of the universe. Those are all contested at the edges, debated in seminars, subject to revision. But time feels different. Time feels like the floor. Every record ever kept depends on it. Every biological process in your body is synchronized to it. It is the one thing that nobody argues about because nobody has reason to. Here is the problem. The measurements are in, and they are not saying what they are supposed to say. Right now, in published science, the following things are all simultaneously true. Earth just recorded the shortest days in the history of precise measurement, and the researchers who study planetary rotation are openly saying the models do not explain it. The Global Authority on Official Timekeeping voted to permanently decouple atomic time from Earth's actual rotation by 2035 because the gap between those two things has become structurally unmanageable. Physicists experimentally reversed electromagnetic waves in time in a laboratory in December 2025. A team at Wheeler measured time running at different rates across a distance of 1 millimeter, and your brain is constructing its own version of time right now using memory, dopamine, and attention, and that version has essentially nothing to do with what the clock on the wall says. Each of those statements is documented. Each has a published paper behind it. None of them feel like they belong in the same conversation. They do. That is not an argument about metaphor or philosophy. It is a claim about what happens when you actually look at what the evidence across every scale is showing. The planet is not spinning the way the models predict. The institutions that manage official time are abandoning the attempt to keep it anchored to astronomical reality. The physics of time at the quantum level does not behave the way the physics of time in daily experience behaves, and the biological timing system that governs almost every process in the human body is being systematically disrupted by conditions we created and have not seriously addressed. These are not separate problems. What they share is this. Every one of them is a case where a system built on an assumption about how time works is running into a reality where that assumption is failing. The arc of what follows moves through each of these levels in sequence. Planetary rotation first, then the institutional response to it, then the physical reality of time dilation at scales you can measure with a magnifying glass, then the quantum level, where time starts behaving in ways that have no everyday analogy, then the biological, where the disruption is already producing a measurable health catastrophe that almost nobody has framed as a time problem. By the end, the question is not whether something is wrong with time. The answer to that is yes. The question is what it means that all of this has been true simultaneously for years and nobody put it in the same sentence. Because what happens when you actually put all of it in the same room is what this is about. On June 29, 2022, Earth had the shortest day since humans started measuring it precisely enough to notice. The day was 1.59 milliseconds shorter than 24 hours. That sounds like almost nothing. And if it came from a bad instrument or a minor calibration drift, it would be nothing. But the instruments measuring this are atomic clocks, and atomic clocks do not drift. They are accurate to within 1 second over several million years. A 1.59 millisecond discrepancy from an atomic clock is not noise. It is a fact. Here is what that measurement actually means. Every day, the International Earth Rotation and Reference System Service, IERS, the body responsible for tracking the planet's spin, compares two things. One is atomic time, which is generated by networks of cesium clocks and is as close to absolute precision as physics currently allows. The other is astronomical time, which is measured by tracking exactly how long Earth takes to complete one full rotation relative to distant reference stars. Those two numbers are supposed to be the same. When they diverge, IERS tracks the divergence and decides what to do about it. On June 29, 2022, the divergence was larger than any previously recorded measurement since this comparison system came into operation. The planet had spun faster than it was supposed to, not by a little, by the largest margin on record. Then July 5, 2024, broke that record again. So what was the long-term trend before this happened? For most of the time humans have been tracking Earth's rotation with sufficient precision, the planet was slowing down. Fractionally, imperceptibly to any human sense, but measurably. Days were getting longer. The reason was well understood. The moon exerts tidal drag on Earth's oceans, and that drag acts like a brake on the rotation. The effect is tiny, about 1.4 milliseconds per century, but it was consistent and predictable. The models accounted for it. The measurements confirmed it. The direction of change was not in question. Then something reversed. Leonid Zotov is one of the world's leading authorities on Earth rotation, based at Moscow State University. His direct quote when the acceleration was measured, "Nobody expected this." That is not a paraphrase or a simplification. That is the actual statement from one of the people who studies this as a primary research focus. The acceleration was outside the range that the standard models predicted, not on the edge of the prediction range, outside it. So, what drives Earth's rotation? The short answer is that it is not one thing. The length of a day is influenced by the distribution of mass across the planet, ice sheets, ocean water, atmospheric pressure systems. It is influenced by angular momentum transfers between the solid outer crust and the fluid layers below it, including the molten outer core. It is influenced by seasonal changes in where atmospheric mass sits. All of these factors are incorporated into the models IERS and research groups use to forecast and explain changes in rotation rate. Ocean mass redistribution is tracked via satellite gravity measurements. Atmospheric loading is calculated from global pressure data. Core mantle coupling, which is harder to measure directly, is estimated from geomagnetic observations. When all of those inputs are combined, the models account for most observed variation. They do not account for what happened in 2022 and 2024. The leading hypothesis for the recent acceleration involves a phenomenon called the Chandler wobble, a slight, irregular oscillation in the axis around which Earth rotates, separate from the long-term pole drift. The wobble was unexpectedly subdued in the years leading up to the record short days, and some researchers believe that dampening may have contributed to the acceleration. Others point to pressure changes at the core mantle boundary. Neither explanation is confirmed. Neither closes the gap between what the models predict and what the measurements show. It is worth being clear about what is actually being claimed here because the numbers are small and it is easy to dismiss them as irrelevant. The question is not whether you will feel 1.59 milliseconds missing from your day. You will not. The question is what it means that the most precisely measured property of the planet we live on, the rotation rate, has departed from every model we have for explaining it. The atomic clocks are not wrong. The astronomical observations are not wrong. The divergence is real, and the physical system that is supposed to produce that divergence is not fully understood. This matters for reasons beyond abstract physics. The entire global timekeeping infrastructure rests on the assumption that Earth's rotation is predictable within known bounds. The IERS manages the relationship between atomic time and astronomical time specifically because that relationship requires active management. When the rotation rate changes in ways that fall outside the model predictions, the management decisions become harder. How much divergence should be allowed to accumulate? When do you intervene? How do you schedule an intervention when you cannot forecast the rotation rate with confidence? Those questions have direct consequences for every system that depends on precise time synchronization. Financial trading platforms, satellite navigation, global telecommunications networks, scientific measurement infrastructure. The rotation anomaly is not just a curiosity for geophysicists. It is an input to systems that the modern world runs on. And the scientific community's current position on what is causing it is not a provisional answer waiting to be confirmed. It is a genuine open question. The candidate explanations exist. None of them fully work. The models that are supposed to account for this do not account for this. And the most direct thing the researchers studying it will say is that they do not know why. Since 1972, the official keepers of global time have been inserting extra seconds into the calendar to stop our clocks from drifting away from the actual rotation of the planet. 27 times. That is how many leap seconds have been added since the system started. Each one represents a moment when the gap between atomic time and Earth's actual rotation grew wide enough that the official timekeepers decided they had to act. Each one is a correction, and a correction, by definition, means something was wrong. Here is the background you need to understand why that matters. Before atomic clocks existed, time was defined by astronomy. A second was a fraction of a solar day. A day was how long it took Earth to complete one rotation. The two things were the same thing, because one was defined in terms of the other. Then, in 1967, the scientific community formally redefined the second using atomic physics. A second became a fixed number of oscillations of a cesium-133 atom under specific conditions. That definition does not involve Earth. It does not involve the Sun. It is a number derived from quantum mechanics, and it never drifts. It is accurate to within 1 second over about 300 million years. Earth is not that accurate. Earth is, in fact, quite sloppy. The rotation is affected by ocean currents, atmospheric pressure, the movement of the molten core, the gravitational pull of the moon. All of it adds up to a rotation rate that wobbles over time, and the long-term trend for most of recorded history was a gentle deceleration. Days were getting fractionally longer, a consequence of the moon's tidal drag pulling angular momentum away from the planet slowly and continuously over billions of years. So when atomic timekeeping became the standard, someone had to manage the gap. The International Earth Rotation and Reference System Service is the body that does this. They monitor the difference between atomic time and astronomical time continuously. When the gap approaches a full second, they announce a leap second. At the designated moment, the official clocks read 23:59:60 before rolling over to midnight. 1 extra second inserted into the record. The gap closes. Everything continues. That is the theory. The practice is considerably messier. In 2012, when a leap second was inserted, servers at Reddit went down. LinkedIn crashed. Qantas, the Australian airline, had to revert to manual check-in at multiple airports because its automated systems failed. Hundreds of other institutions reported problems. The root cause was the same in almost every case. Computer systems are not designed for a minute that contains 61 seconds. The software assumed that was impossible. The assumption was wrong. This is not a fringe concern. The entire architecture of networked digital infrastructure runs on timestamps. Financial systems record transactions to the millisecond. Distributed databases synchronize across servers using time as the reference. Security protocols use timestamps to verify authenticity. When a second appears that no system expected, the failure modes are unpredictable and varied because every developer who wrote every piece of affected software made the same reasonable assumption that time moves forward in uniform increments and never pauses or repeats. A leap second is a second that appears from nowhere. The internet is not built for that. The engineering workarounds developed after 2012 included techniques like the Google leap smear, where the extra second is spread across the surrounding hours as a continuous fractional adjustment rather than a discrete insertion. It works, but it means different systems are running on slightly different times during the smear window, and that introduces its own category of subtle errors that are harder to detect because they do not cause immediate crashes. So in November 2022, the Bureau International des Poids et Mesures voted to eliminate leap seconds by 2035. The decision was not controversial within the timekeeping community. The consensus was that the infrastructure risk was no longer acceptable. The practical case was straightforward. What the practical case does not fully address is what the decision actually means. We are not fixing the divergence between atomic time and Earth's rotation. We are stopping the practice of correcting it. After 2035, the two timescales will be allowed to drift apart without limit, for the first time since standardized global time existed. The current tolerance, which requires a correction whenever the gap approaches 1 second, will be replaced by a tolerance of something closer to 1 minute, then eventually more over the coming century. The planet does not care about this decision. Earth will keep rotating at whatever rate the oceans, the atmosphere, and the molten core determine. The gap will keep widening. We will simply stop patching it. There will come a point, probably around a century from now, where official noon and the actual peak of the sun in the sky no longer coincide, not by a second, by a noticeable margin. That is a choice humanity made, not under duress, deliberately, after deliberation, as the cleanest available solution to a technical inconvenience. We decided the cleanest solution was to stop keeping track of the difference, and the planet will keep drifting, and in 100 years that gap will be large enough that noon and the sun's peak will no longer match, and we have formally decided that is acceptable. There is a mechanism connecting climate change to the length of a day that almost never appears in the same conversation as the ice sheets and the sea levels. The conversation about climate change has a familiar shape: temperatures rising, sea levels climbing, extreme weather intensifying. Those are the headline effects, and they are real and they are serious. But there is a physical consequence sitting underneath all of them that almost never gets named directly. When you melt ice at the poles, you do not just add water to the ocean, you move mass. You take weight that was concentrated near the rotational axis of the planet and you spread it outward toward the equator. And that redistribution has a consequence that follows directly from basic physics, the kind that does not require any disputed modeling or contested projections. It is the same physics as a figure skater. When a skater pulls their arms in close to their body, they spin faster. When they extend their arms outward, they slow down. No external force is applied. Nothing pushes them. The change in spin rate comes entirely from the redistribution of mass relative to the axis of rotation. This is conservation of angular momentum. It is not a contested principle. It is the kind of physics that shows up in every introductory mechanics course on Earth. And it applies to planets the same way it applies to skaters, because a planet is just a large rotating body and the same rules govern it. As the Greenland ice sheet and the Antarctic ice sheet lose mass, the water they were holding does not stay at the poles. Ocean circulation carries it toward lower latitudes. The equatorial regions accumulate that redistributed water. Mass moves away from the rotational axis. The planet extends its arms, and by the same principle that slows the skater, the planet slows its spin. Days get fractionally longer, not by amounts you would feel, not by amounts that matter on any human timescale, but by amounts that are real, measurable, and accumulating. Researchers have quantified the rate. From 2000 to 2020, climate-driven mass redistribution was lengthening the day by approximately 1.33 milliseconds per century. That number may not sound significant. Here is why it is. Scientists compared that rate against the geological record going back 3.6 million years. The rate of day lengthening driven by this mechanism has no parallel in that entire span. We are not talking about an anomaly that falls outside the range of normal variation by a small margin. The pace at which melting ice is currently affecting Earth's rotation is without precedent in the available record. This is already happening. It is not a projection of what will occur if warming continues. It is in the data for changes that have already taken place. So climate change is altering the length of a day, not as a metaphor for how the world feels different now, literally, physically, in a way that shows up in the atomic clock comparison records that the International Earth Rotation and Reference Systems Service maintains. The same system that detected the short day records in 2022 and 2024 is also recording the long-term slowing signal from ice mass redistribution. Both effects are visible in the same dataset. And here is where it becomes genuinely difficult to hold in one frame. The short-term acceleration that researchers described as unexpected, the one that nobody's models fully account for, is pulling the rotation in one direction. The long-term climate-driven deceleration is pulling it in the other. Two distinct forces, both active, both measurable, both driven in part by changes occurring in the present era, operating simultaneously and in opposition. The planet is being pushed toward faster rotation by something the models have not fully identified, and pulled towards slower rotation by the physical consequence of ice melt that the models do account for. Neither effect is hypothetical. Both appear in the published literature. Both have active research programs trying to characterize them. And they are running at the same time, which means the actual net rotation of the planet at any given moment is the sum of competing forces that are not all fully understood. What does that mean for the timekeeping problem? We already established that humanity has decided to decouple official time from Earth's actual rotation by eliminating the leap second by 2035. Part of the stated justification for that decision is that the rotation has become too unpredictable to patch reliably. You can read this as bureaucratic convenience. You can also read it as an honest acknowledgement that the planet's rotation is now behaving in ways that make long-term prediction genuinely difficult. Both readings are probably correct. One force from melting ice is slowing the planet, and another unexplained force is speeding it up, and both are running simultaneously, and the net result is a rotation that the best models currently available cannot fully predict. The most unsettling thing Einstein ever said was not about relativity in the abstract. It was the implication that two people standing at different altitudes are literally aging at different rates. Not aging differently in some philosophical or metaphorical sense, physically, measurably. The person standing at sea level and the person standing on a mountain are moving through time at different speeds. Einstein published the mathematics of this in 1915, and for most of the century that followed, it remained exactly that, a prediction, a result you could derive on paper and verify indirectly. That distance closed in 2022. A team at Gila, a physics research institute in Colorado, took the effect that Einstein described and measured it at a scale of roughly 1 millimeter. Two groups of ultra-cold strontium atoms loaded into an optical lattice, a structure built from intersecting laser beams, separated vertically by a distance about twice the width of a human hair. That is the entire experimental setup. That is the gap. And the lower atom's clock was ticking measurably slower than the upper atom's clock, not inferred, not extrapolated from equations, directly measured in a tabletop experiment at a scale you could inspect with a magnifying glass. Why does this happen? Because gravity is fractionally stronger 1 millimeter lower. The gravitational field of the Earth pulls harder at the bottom of the apparatus than at the top. And according to general relativity, stronger gravity means slower time. Mass curves space-time. The deeper you sit in that curve, the slower your clock runs. Einstein's equations predict the magnitude of the effect with extraordinary precision, and the Gila measurement matched those predictions exactly. The effect is extraordinarily small, but it is real and it is there at 1 millimeter of separation. Here is what that means. It means there is no altitude on this planet where time runs at a single universal rate. Every floor of every building has atoms aging at a slightly different pace than the floor below it. The ground outside your door is running fractionally slower than your second floor window. This is not a quirk of extreme physics. It is the ordinary behavior of time under gravity, and gravity is everywhere. Now consider GPS. The global positioning system depends on a constellation of satellites orbiting at roughly 20,000 kilometers above Earth's surface. At that altitude, the gravitational field is weaker than it is on the ground. Weaker gravity means faster clocks. Each GPS satellite carries an atomic clock, and those clocks run fast by approximately 45 microseconds per day relative to clocks at the surface. That is the gravitational component alone. There is also a velocity effect. The satellites are moving fast enough that special relativity contributes an opposing correction, slowing the satellite clocks by about 7 microseconds per day. The net result is that GPS satellite clocks gain roughly 38 microseconds per day compared to clocks on the ground. 38 microseconds sounds like nothing. It is not nothing. The speed of light is approximately 300 meters per microsecond. 38 microseconds of uncorrected clock drift, compounded over a day, would introduce position errors of several kilometers every day, without correction. Your GPS-based navigation would be useless within hours of the system going live. So what did the engineers do? They baked the relativistic correction directly into the satellite software before launch. The clocks on GPS satellites are deliberately tuned to run slightly slow on the ground, so that once they reach orbit and gravity weakens, the rate corrects to match ground-based time. This is not a theoretical gesture toward completeness. It is a load-bearing piece of engineering that the entire system depends on. Every time your phone locates you within a few meters, it is doing so because someone accounted for the fact that time runs faster in orbit than on the ground. Ask yourself what that actually means. The civilian technology you use to find a restaurant or navigate an unfamiliar city only works because the engineers who built it accepted Einstein's equations as literally true and correct, not as useful approximations, not as elegant theory, as operational fact accurate enough to stake precision navigation on. The physics is not abstract, it is in the infrastructure, and the Gila experiment takes this further. If 20,000 kilometers of altitude difference produces a measurable and consequential time rate change, and 1 millimeter produces a directly measurable time rate change, then there is no sensible place to draw a line and say, below this scale, time is uniform. It is not uniform at any scale. Every position in space has its own local time rate, set by the local gravitational field, continuous and graded all the way down. That is what general relativity actually says. Not that time slows down near black holes in science fiction. That time is a gradient everywhere, right now, at every scale, including the scale of your own body. The top of your head is aging fractionally faster than the soles of your feet. The numbers are too small to matter biologically, but the physics does not have an exception clause that starts mattering below a certain size. There is no single universal now. there is only a gradient of time rates, pulled and stretched by gravity at every scale from a millimeter to the distance between planets, and the GPS system in your pocket is proof that this is not theory anymore. Go small enough and time stops behaving like time. Not metaphorically, not as a philosophical point. The experiments are in and the results are direct. At the quantum scale, time does not work the way every clock, calendar, and intuition you have ever used would suggest. What the last section covered was time running at different rates depending on gravity. That is strange. What we are about to cover is stranger, because at the quantum level, the question is not how fast time runs. The question is whether it runs at all. Start with time crystals. A regular crystal is a structure where atoms arrange themselves in repeating spatial patterns. Salt, quartz, diamond, the atoms line up in a grid, a lattice, a geometry that repeats across space. That spatial repetition is what makes a crystal a crystal. Now imagine the same thing happening across time instead of space. Not a pattern in where the atoms are, a pattern in when they are. A system that oscillates between states at perfectly regular time intervals, spontaneously, without any energy being added to drive it. The system breaks time symmetry the way a snowflake breaks spatial symmetry. No external force required, just a structure that repeats through time on its own. This was theoretical for years. The idea was controversial when it was first proposed because it seemed to violate basic thermodynamic principles. A system that just oscillates forever without energy input looks like a perpetual motion machine if you are not careful about the distinctions. But the distinctions matter. Researchers at TU Wien confirmed a new class of time crystal in 2025. It is not a perpetual motion machine. It is a phase of matter where the ground state has temporal structure. It exists, it has been measured, and what it tells you is that time, at the quantum level, has an internal geometry that can be broken the way spatial geometry is broken by a crystal. Time has symmetry, and that symmetry can be violated. That is already a significant result, but it is not the most unsettling one. In December 2025, physicists experimentally reversed electromagnetic waves in time. Not in space, in time. The process is called time reflection. When a wave hits a spatial boundary, part of it reflects back through space. That is ordinary reflection, the kind that gives you your image in a mirror. Time reflection is different. The wave retraces its path backward through time rather than backward through space. This had been a theoretical prediction for decades. The mathematics allowed it. Nobody had confirmed it in a laboratory until late 2025. Now they have. You can take an electromagnetic wave and cause it to move backward through time. The experiment does not violate causality in the way science fiction would suggest, but it does confirm that the forward direction of time is not a har. Deconstraint at the quantum level. It is a feature that can, under the right conditions, be reversed. That is not a thought experiment anymore. It is a documented laboratory result. Here is where the discomfort becomes structural. There is a deeper problem underneath the time crystals and the time reflection, and it does not come from a new experiment. It comes from looking carefully at an equation that has been in the literature for decades. In 1967, physicists John Wheeler and Bryce-DeWitt wrote down the equation that should describe the quantum state of the entire universe, the Wheeler-DeWitt equation. It is the quantum gravity analog of the Schrödinger equation, the equation that governs how quantum systems evolve. If you want to know how the wave function of the universe behaves, this is the equation you write down. And when you write it down, something is missing. Time. The variable does not appear. Not in a way that can be recovered by a change of notation or a mathematical trick. The equation has no time parameter. The wave function of the universe in this formulation is static. It does not evolve. There is no before or after built into the description. What we experience as the flow of time, the sense that events occur in sequence, that the past is fixed and the future is open, does not emerge from that equation directly. It has to be constructed from the correlations between the components inside the wave function. Time, at the most fundamental level of physical description available, is not a given. It is an output, something that appears to exist at the scale we can see and measure but has no fundamental existence at the scale the equations describe. We experience time, we measure it, we build civilizations on top of the assumption that it is the most stable thing there is. and the equation that describes the quantum state of the entire universe, the most fundamental physical description we have, contains no time variable, which means the thing you are most certain is real does not appear in the deepest description of what reality is. Your brain does not have a clock. It has a construction process that assembles the experience of time out of memory, attention, and neurochemistry, and none of those things are neutral. That is worth pausing on. We have spent the last section looking at a universe where the fundamental equations do not include time. Now we come back to the human scale and find the same problem running in the opposite direction. Not time missing from the equations. Time present in your experience but constructed from materials that have nothing to do with how long anything actually took. The physicist and the neuroscientist land in the same place from different directions. Time, at the level where it feels most real and most personal, is assembled. It is not read off a dial. It is built. Here is what the building involves. There is no single time region in the brain. The prefrontal cortex, the cerebellum, the basal ganglia, all of them contribute. Different circuits for different scales of duration. Different systems for prospective timing versus retrospective judgment. The brain does not have one clock. It has a committee, and the committee does not always agree, and the output it produces depends heavily on what kind of information the committee was given to work with. The governing variable is memory density. That is the core mechanism. When you experience something novel, something your brain has not processed dozens of times before, the encoding process is intensive. More detail, more associations, more cognitive resources devoted to building the memory. And when you look back at that period later, your brain reads the density of the memory as evidence of duration. Rich memory equals long time. That is the heuristic the retrospective system uses. It has no other way to estimate. Familiar routines work in reverse. A morning you have repeated 300 times generates almost no new memory material. Your brain is running on autopilot, encoding almost nothing. And when you look back at the week, it feels compressed. It barely existed. Here is the inversion that most people do not notice. In the moment, a boring or routine stretch can feel slow because your attention has nothing to process. But in retrospect, it vanishes. The moment felt long. The memory is brief. Those are two completely different time experiences for the same interval, and your brain is producing both of them. This is why childhood summers felt endless. Not because they were longer. They were exactly as long as every other summer. Children are encountering novelty at a rate adults almost never match. Every experience is being encoded in detail because the brain has not built templates for it yet. The density of childhood memory is extraordinary compared to adult memory of equivalent calendar time. Look back at a summer from age 9 and there is material there. Look back at a summer from age 34 spent in the same job, the same apartment, the same routine, and it is nearly featureless. Not because nothing happened, because the brain stopped recording. Now look at what happens under acute danger: a car accident, a sudden fall, a moment of genuine physical threat. People report it consistently and reliably. The event seemed to last far longer than it did. This is not metaphor. It is not people being dramatic. It is a specific neurological event with a documented mechanism. The amygdala fires. Norepinephrine floods the system. The brain shifts into a high-fidelity recording mode, encoding every available detail of the threatening moment with unusual density and precision. When the person reconstructs the event afterward, the brain reads that dense encoding as evidence that the interval was long. Time dilates, not metaphorically. That is what the nervous system is doing. It is deciding the moment is too important to compress and recording accordingly. What does that mean practically? It means the brain does not measure time. It infers time from the quality of what it recorded. High-quality recording equals long duration. Low-quality recording equals short duration. The experience of time is downstream of the encoding decision, and the encoding decision is governed by novelty, threat, emotional significance, and attentional load. None of those things have any relationship to a clock. Here is the part that almost never gets stated plainly. Dopamine is involved in timing perception. The dopaminergic system is not peripheral to how the brain estimates duration. It is central to it, and dopamine levels decline with age. This is not controversial. It is well established in the neuroscience of aging. The loss is gradual, it varies across individuals, but the direction is consistent. Dopamine goes down. What follows from that is that the neurochemical changes of aging are directly accelerating subjective time, not because of memory density alone, not just because routine crowds out novelty, but because the underlying timing mechanism is operating with less of the neurotransmitter that calibrates it. Lower dopamine, faster subjective time. The internal pacemaker, such as it is running at a different rate than it did at 20. The experience of years passing quickly as you age is not a cliché about getting older and being busy. It is a measurable biological phenomenon with a documented neurochemical driver. That is an extraordinary thing to sit with. We spend enormous effort measuring time on the outside. Atomic clocks accurate to a second over millions of years. Satellites corrected for relativistic drift. Official timekeeping bodies maintaining the global standard. And the biological system doing the actual experiencing of time inside every human being on the planet is degrading its calibration quietly with each decade, and almost nobody frames it that way. The subjective acceleration of time with age is not a feeling or a cliché. It is a documented neurochemical effect driven by dopamine decline, and most people will never hear that explained in terms that make it that concrete. The human circadian system evolved across millions of years to do one thing: synchronize the body with the light-dark cycle of a rotating planet. That is not a poetic description, it is a functional one. The circadian clock is not one system among many in the body. It is the master timing signal that every other system is organized around. Sleep architecture, cortisol release, insulin sensitivity, immune activity, cell division and repair, body temperature regulation, mood, all of it runs on a 24-hour schedule that the brain sets by reading light. Specifically, by reading the presence or absence of short wavelength blue light hitting the photoreceptive cells in the retina. When those cells detect blue light, the suprachiasmatic nucleus in the hypothalamus interprets it as daytime. It suppresses melatonin. It shifts hormone cascades into waking mode. When blue light disappears, the system reads that as night and begins the sequence. In reverse, this is not complicated. It is also not negotiable. The body does not have a manual override for this process. It responds to the signal it receives. Here is the problem. The signal it is receiving now is not the signal it evolved to read. Artificial light, and specifically the blue spectrum light from LED screens, overhead lighting, street lamps, and phone displays, is chemically identical to the signal the circadian system uses to detect day. The photoreceptors in the retina cannot distinguish between sunlight at noon and a phone screen at 11 at night. Both register as daytime. Both suppress melatonin. Both tell the body to stay in waking mode. It does not matter that you know it is night. The system below your conscious awareness is reading the light and running its program. And the light says it is not night yet. Over 80% of people in developed nations now live under light conditions that their circadian systems read as permanent partial day. The darkness that would normally trigger the biological transition into night never fully arrives. 99% of people in the United States and Europe are exposed to enough artificial light pollution that 2/3 of Europeans cannot see the Milky Way. That figure is usually treated as a statement about astronomy. It is a statement about biology. If the sky is bright enough to wash out the Milky Way, the light environment has already crossed the threshold that disrupts melatonin timing, delays sleep onset, and compresses the hormonal window the body uses to run its nighttime repair sequence. What does that mean over time? This is where the data becomes hard to look away from. Circadian disruption is now formally associated in the published literature with obesity, metabolic syndrome, type 2 diabetes, hypertension, cardiovascular disease, multiple neurodegenerative conditions, depression, and cancer. These are not speculative links. They are replicated across populations and study designs. The mechanism is understood well enough to explain most of them. Insulin sensitivity follows a circadian rhythm. Immune activation follows a circadian rhythm. The cellular repair processes that clear damaged DNA and dysfunctional proteins run primarily during deep sleep. When the timing of sleep shifts, compresses, or fragments because the light signal that triggers it is chronically delayed, all of those processes run late, run short, or run out of sequence. The clearest evidence for this comes from night shift workers. People who work regularly against their circadian schedule, who are awake during the biological night and sleeping during the biological day, show dramatically elevated rates of almost every condition on that list. The World Health Organization classified night shift work as a probable carcinogen in 2007. That classification is based on epidemiological data consistent enough across multiple countries that the committee considered the link likely causal, not merely correlational. Night shift work is the extreme version of what happens when the circadian system is chronically misaligned with the actual light-dark environment. Now here is the part that should be getting more attention. The general population is running a less extreme version of the same experiment. Staying up 2 hours past sunset looking at a screen is not the same as working overnight at a hospital, but it is not neutral either. It shifts the circadian phase, it delays melatonin onset, it shortens the biological night, and it is something close to universal across developed nations. The average adult in the United States is exposed to screens for more than 7 hours per day. A significant portion of that exposure happens after dark. The circadian system is receiving a light signal that does not match the actual rotation of the planet, and it is adjusting its timing accordingly, and the physiological consequences of that adjustment are accumulating across populations in ways that show up clearly in epidemiological data. We did this without a formal decision. There was no policy. There was no impact assessment. Electric light was a technological achievement, and then it was the commercial product, and then it was the default condition of modern life, and the question of what it was doing to the biological timing systems of the people living inside it was not part of any of those conversations. That is worth sitting with. We changed the light environment for an entire species. We did it gradually, then completely. And the downstream biological cost of that change has been attributed to diet, to stress, to genetics, to aging, to almost anything except the most obvious candidate. The disease burden from that disruption is embedded in every major health dataset we have, and the conversation about it almost never connects back to the fact that we changed the timing of light and dark for an entire species and then moved on. Twice a year, most of the world participates in the collective fiction that we can move time by an hour and that this will be fine. We have been doing this since the early 20th century. The original justification was energy conservation, loosely tied to agricultural schedules and the idea that more daylight in the evening would reduce lamp and candle use. That justification has not been relevant in any serious sense for generations. The agricultural sector, which the policy was supposedly designed around, has consistently opposed daylight saving time because livestock and crops do not adjust on command. The sun does not adjust. Only the clocks adjust, and only the humans who depend on those clocks bear the cost. Here is what that cost looks like in the data. A 2018 study documented up to a 29% increase in heart attacks in the days immediately following the spring transition. That number is not a projection. It is a measured increase, replicated across multiple countries and multiple research groups. Traffic fatalities go up. Workplace injuries increase. Cognitive performance drops measurably and stays depressed for several days after the change. None of these are subtle statistical artifacts buried in noise. They are consistent effects, documented in peer-reviewed literature, confirmed repeatedly, and attributed directly to a single hour of forced sleep disruption applied simultaneously to hundreds of millions of people. What kind of policy produces a 29% spike in heart attacks twice a year and remains in place? The answer is a policy that has never been treated as a health question. Daylight saving time has been managed as an administrative and economic issue for its entire history. The health consequences have been known for years. The economic justifications have been studied and found weak or contradictory. At least 54% of the public wants it gone. The medical community has been formally calling for its elimination. The evidence is not ambiguous and has not been ambiguous for a long time. And yet the policy persists. Why? The honest answer is coordination failure. No single jurisdiction wants to break from the regional standard unilaterally because the disruption of being out of sync with neighboring states or countries creates its own problems. So the reform is perpetually staged for the future, pending agreement, waiting on legislation that gets proposed and stalled in cycle after cycle. The political cost of changing it is diffuse and the benefit is hard to claim individually, so nobody moves. The result is that we keep a policy that we know kills people because the bureaucratic difficulty of synchronizing a change across borders has never been treated as urgent enough to solve. That is the first thing daylight saving time reveals. The second is larger. If we are willing to move time by an hour twice a year for reasons that do not hold up to scrutiny, it means we already understand, at some institutional level, that time as socially experienced is malleable. It is not a fixed fact, it is an agreement, and agreements can be renegotiated. The time zones themselves are not natural phenomena. They were drawn by committees. Some of them are drawn in ways that make no geographic or astronomical sense, because a city lobbied to be included in an economically advantageous zone, or a national government decided that unity across a vast territory mattered more than alignment with the sun. China runs on a single time zone for a country that spans what should be 5 parts of. If Indiana spent decades refusing daylight saving while surrounding states observed it. Time, as we actually live it, is a political document. It reflects who drew the lines and when and why. It is enforced by legislation, not by physics. The sun does not know what the clock says. Your circadian system does not know what the clock says. It knows when light appears and disappears. The clock is a social agreement layered on top of a biological and astronomical reality, and the agreement is maintained by inertia more than by logic. What this section of the problem shares with every other section is the same structural fact. We built a system on an assumption, the assumption calcified into policy, and now the policy persists past the point where the assumption still makes sense, and the cost is paid in measurable human health outcomes that we have chosen, collectively and repeatedly, not to treat as urgent enough to change. We have a policy that we know causes measurable death, applied twice yearly, that nobody has had the political coordination to eliminate, and what that reveals about how seriously we take the management of time is not flattering. There is a version of the time problem that operates at a scale where human intuition stops working entirely. Not the rotation problem, not the leap second problem, not even the relativistic gradient measured across a millimeter. Those are strange, but they are still operating inside a frame your nervous system can process. What happens at geological timescales is different. The numbers stop meaning anything. You read them and you register them and you do not actually feel them, because the brain that evolved to track seasons and lifespans and generations has no machinery for 56 million years. It hears the number, it does not understand it. And that gap between hearing and understanding is where our entire interpretation of the deep past goes wrong. Here is a frame that might break through. Earth is approximately 4.5 billion years old. 56 million years ago sounds ancient. It is also less than 1.5% of Earth's total age. If you compressed all of Earth's history into a single calendar year, 56 million years ago would be somewhere in the last week of December. The PETM, the carbon event with the unexplained biological fingerprint, happened last Tuesday in that calendar. Modern humans appeared roughly 4 hours ago. Everything you know as recorded history fits inside the last 90 seconds, and we are not built to see it that way. Now take the PTM on its own terms. It lasted approximately 200,000 years. That is the duration of a single geological event considered brief in the literature. Brief. 200,000 years. The entire span of anatomically modern human existence is somewhere around 300,000 years. So the PTM, the thing that gets a paragraph in earth science textbooks before the chapter moves on, lasted roughly 2/3 as long as our entire species has existed. The rise of every human civilization, every language, every technology, every war and empire and agricultural system, all of it fits inside 1/3 of the duration of a geological footnote. What does that mean for how we read the record? It means that when a geologist says an event was rapid, they are describing a window that could contain the complete arc of a technological civilization, from its first tools to its last structure, and leave nothing behind but chemistry. That is not a rhetorical point. That is the actual constraint. Frank and Schmidt modeled it directly. They asked what would remain in the geological record if a civilization comparable to ours had been present for tens of millions of years ago, and the answer was specific and short. Isotope ratios locked into carbonate rock, trace metal concentrations at sites of industrial activity, carbon volume and fingerprint recorded in deep sea sediment. That is the complete list. No concrete, no steel, no plastic, no indication of intent, no signal that anything wit Shamain produced any of it. Structures collapse within thousands of years. Steel corrodes within tens of thousands. Plastic breaks down within hundreds of thousands. All of it gone before a single million years has passed. The geological record cannot retain how events unfolded. It captures only the chemical residue of what happened. And those are not the same thing. The fire analogy holds here the same way it held for the PETM. You find the ash. You measure how hot it burned. You do not find the building, and you do not find anything that tells you a building was there at all. Now ask the harder question. If the record can only preserve chemistry, and if a brief geological event can span the full lifespan of a technological civilization, what exactly are we claiming when we call the geological record complete? We are claiming that the residue is the event. We are looking at the ash and concluding there was no building because we cannot find the walls. That is not rigor. That is a limitation of the evidence being mistaken for a conclusion. This is the distortion, not a conspiracy, not an institutional cover, a structural problem built into the nature of preservation itself. Deep time erases the signal and leaves the noise, and we have developed elaborate interpretive frameworks built entirely on the noise, and we treat those frameworks as confident histories of what the planet was doing. In most cases, that is the best we can do, but the confidence we attach to those frameworks does not match the evidence they are built on. The PETM carbon anomaly has a biological fingerprint. The volume exceeds what known natural sources can account for. The rate of release, by geological standards, was fast enough to encompass a complete civilizational cycle and leave no physical trace. Frank and Schmidt produced a formal model saying a prior civilization would be indistinguishable from a geochemical event, and the gap in the PETM explanation has sat open for 30 years without closing. Is that proof of anything? No. What it is a precise illustration of the distortion. The record hands us a chemical signal, we cannot identify the source, and the best framework we currently have for interpreting signals like that specifically predicts we would be unable to identify the source, even if the source was something we would recognize immediately if we could see it directly. That is where deep time puts us. Not in ignorance exactly, in a structural blindness that the tools themselves cannot correct for. The filter removes the most diagnostic information and delivers only the residue, and the residue is what we have, and we have called it enough. We read the chemical residue of whatever happened and call it a complete account, and the gap between those two things is where everything we cannot explain about the deep past is living. What becomes visible when you hold all of this in one frame is that these are not separate problems. The rotation anomaly is not a geophysics story. The leap-second elimination is not a bureaucratic story. The millimeter-scale time dilation is not an abstract physics story. Each one of these, isolated, looks like a niche scientific footnote, but put them in the same room and the picture changes. What you are looking at is a single assumption, that time is stable, regular, and shared, failing at every level of physical and biological reality simultaneously. That is not a footnote. This is where the real issue emerges. This is what links the planetary and physical dimensions together. Earth's rotation is currently behaving in ways that the best available models do not fully explain. The short day anomaly from June 2022, 1.59 milliseconds under 24 hours, was not projected. The researchers tracking it said directly that they did not expect it. At the same time, general relativity tells us that clocks do not run at the same rate depending on where you are standing. A clock at sea level and a clock 1 millimeter higher are running on measurably different schedules. GPS engineers already bake that correction into every satellite in orbit, 45 microseconds per day, because without it the system drifts into uselessness within hours. So when we say Earth's rotation is accelerating in ways no model accounts for, we are talking about a planet where no 2 points on the surface are even sharing the same time rate, now also spinning in an anomalous pattern that the field cannot explain. These are not metaphors. Both are measured. Both are documented. Now add the institutional layer. In 2022, the Global Timekeeping Authority voted to eliminate leap seconds by 2035. Think carefully about what that decision means. Since 1972, leap seconds have been the mechanism for keeping official atomic time aligned with the actual rotation of the planet. 27 insertions, 37 total seconds added to the record. The decision to stop was driven by infrastructure fragility. Digital systems cannot handle a second that appears from nowhere without breaking. That is a real problem. But the solution chosen was not to fix the fragility. The solution was to permanently decouple official human time from astronomical reality. The planet will keep drifting. We will stop tracking by how much. That is not a technical refinement. That is a formal institutional decision to let the gap grow indefinitely. A century from now, noon on the official clock will no longer correspond to the sun at its peak, and the institutions responsible have already decided that is acceptable. So, the biological layer is where it stops being abstract. The human circadian system evolved across millions of years to synchronize with the light-dark cycle of a rotating planet. That synchronization governs hormone release, immune function, cell repair, and metabolic timing in a precise 24-hour sequence. It is not a preference. It is the operating schedule of the body. More than 80% of people in developed nations now live under light conditions that their circadian systems interpret as permanent, incomplete night. The consequences are in every major health dataset: obesity, metabolic syndrome, hypertension, neurodegenerative disease, depression, elevated cancer risk. It is presented as a lifestyle problem, a screen problem, a sleep hygiene problem. It is a time problem. We changed the light environment of an entire species without accounting for the timing system built around that environment, and the biological cost of that decision is now being measured in population-level disease rates. So, the perceptual layer sits underneath all of it. Your brain does not receive time, it constructs it. Memory density governs retrospective time perception. Novel experiences generate dense encoding, and those periods feel long in retrospect. Familiar routines generate sparse encoding, and those periods compress. Dopamine levels fall with age, and the dopaminergic system is involved in interval timing, which means the neurochemical changes of aging are literally accelerating subjective time, measurably, in ways that are documented and almost never explained in those terms. Every person is running a different internal clock, calibrated by their own neurochemistry, their own history of novelty and routine, their own stress response. There is no moment at which two people in the same room are experiencing time at the same subjective rate. That is not philosophy, that is neuroscience. So, and at the geological scale, the distortion compounds. The chemical residue of ancient events is what the geological record preserves, not events themselves, not their causes, the aftermath. Frank and Schmidt modeled this formally in 2018. A sophisticated culture operating at technological and resource levels matching our own could have existed, exhausted its material base, and vanished. Yet the geological signature would appear indistinguishable from a chemical anomaly, a name in a textbook, an open gap in the explanation. The PETM has been studied for 30 years. The biological carbon fingerprint is confirmed. The volume exceeds the known natural sources. The gap is sitting there, undisclosed, in the published literature. We do not know what produced it. What we know is that our ability to read deep time is structurally limited in ways that mean the most important events that might have occurred could be unreadable in principle. That is not a temporary gap waiting for the right research program. That is a hard limit built into the nature of geological preservation. So here is the position this leads to. The rotation is off. Official time is being permanently decoupled from the planet. Clocks tick at different rates 1 millimeter apart. The fundamental equations of quantum mechanics contain no time variable. The biological timing system of the species has been systematically disrupted for decades. Every person's subjective clock is running on different neurochemistry, and the geological record is structurally blind to the most consequential events in deep time. Each of these is a documented fact. Each one has its own research literature, its own set of specialists, its own carefully scoped conclusion. What does it mean when the most basic assumed constant, the thing every other measurement and record and memory depends on, is this unstable at this many levels at once? We are the first civilization with instruments precise enough to measure time at every scale from a millimeter to 56 million years, and what those instruments are showing us is not reassuring. Every scale we have looked at has returned the same finding, not the same data. the same type of answer. Something assumed to be fixed is not fixed. Something treated as a foundation is behaving like a variable, and the institutions responsible for maintaining the official version of time have been quietly patching the gap for decades rather than explaining it. That is worth being direct about. The leap-second system was not a minor technical adjustment. It was an admission that atomic time and Earth time are running at different rates and diverging. 27 insertions over 50 years, each one a correction, each one a signal that the underlying system does not hold without intervention. And the response to that in 2022 was not to understand the divergence better. It was to stop measuring it officially. The decision to eliminate leap seconds by 2035 is a formal institutional choice to decouple our constructed time from astronomical reality. Not fix the gap. Decouple from it. Ask yourself what that means. We built a timekeeping system to track how the planet moves. The planet stopped moving the way the system expected, and the solution we arrived at was to stop tracking the planet. That is not an engineering solution. That is a decision about what we are willing to acknowledge. The circadian story follows the same pattern. We redesigned the light environment of an entire species. We moved artificial light into the night hours across every developed nation on Earth. We did this without any formal reckoning with the biological timing system that evolved across millions of years inside exactly the kind of light-dark cycle we were eliminating. The consequences accumulated: metabolic disruption, cardiovascular disease, depression, cancer risk, all of it documented, none of it connected, in any serious public conversation, back to the moment we changed the timing of light. The assumption was that the body would adapt. It did not adapt. The body is not built to adapt to that, and the evidence has been in the data sets for years. The rotation anomaly is the same structure again. Models built on known physical mechanisms, tidal drag, core movement, atmospheric pressure, produced predictions that matched observed data for decades. Then the data moved. The planet accelerated in ways the models did not account for. The researchers were direct about it. Nobody expected this. That quote is not from a fringe source. It is from one of the foremost authorities on Earth rotation, published and on record. The models do not close. The explanation is not complete. 3 separate systems, 3 separate research communities, 3 versions of the same event, a framework built on an assumption about how time behaves, running into a reality where the assumption is not holding. Here is my position on that pattern. When the same structural failure appears at the planetary scale, the institutional scale, and the biological scale simultaneously, the explanation is not 3 independent coincidences. Something about the assumptions themselves is wrong. The assumption that time is a stable background constant, uniform and reliable, against which everything else can be measured. That assumption is embedded in every level of the systems that are now failing. And the failure mode in each case is quiet, drift, not rupture. A millisecond here, a circadian mismatch there, an open gap in an explanation that was filed and not revisited. That is the mechanism to understand. These errors do not announce themselves. They accumulate below the threshold of immediate alarm, and the institutions tasked with managing them have, in each case, responded by adjusting the official record rather than closing the explanatory gap. Is that a conspiracy? No, it is something more ordinary and more difficult to fix. It is the professional cost of following the question where it leads. It is the accumulated weight of systems that were built for a version of time that the measurements no longer fully support. It is what happens when the gap between the model and the reality grows slowly enough that each individual decision to not address it seems reasonable at the time. The cost of pretending the foundation is stable while the measurements say otherwise accumulates exactly the way every uncorrected error accumulates, quietly in the background until the day it isn't quiet anymore.